Okay, oxidation numbers. Oxidation numbers is like a fancy term for its temporary charge. Okay, so think of it as charge. What is the charge of something? What is the charge of oxygen? What is the oxidation number for oxygen? Okay, here's rules for determining oxidation numbers for an atom in its elemental form. Like this is in its elemental form right here. Okay, the oxidation number is 0. It has no charge. Nice and easy. For a monatomic ion, its oxidation number is equal to its normal charge that you guys learned last year. So magnesium +2, its oxidation number is +2. Chlorine -1, -1. The oxidation number for oxygen in its molecular compound is -2. Okay, so when you see oxygen, majority of time it's going to be -2. Right here, -2. Okay, there's 2 of them, so its overall charge is -4, but its oxidation number is -2. Now there are exceptions. Peroxides, like hydrogen peroxide. Right here, hydrogen peroxide. Okay, it's got an overall charge of -2, but its oxidation number is -1. There's two oxygens, each with the charge of -1. Therefore, its overall charge is -2. Okay, but for the majority of time, oxygen will be -2. There are exceptions, though. All right, hydrogen. Hydrogen will be +1 when it's bonded to a nonmetal, like chlorine. It can be -1 when it's bonded to a metal, magnesium hydride. For other covalent compounds that do not contain hydrogen or oxygen, the most electronegative element has an oxidation number equal to its charge. That means, first of all, do you guys remember electronegativity increases going this way and up on the periodic table? Okay? So if I'm looking at this, fluorine is the most electronegative, so it's going to get its common charge of -1. Okay, chlorine is more electronegative than phosphorus, so chlorine will get its normal charge of -1. The sum of the oxidation numbers for all the atoms in a compound must equal the overall charge. For example, water's overall charge is 0. So if oxygen is -2, hydrogen must be +1 since there's 2 of them. That's a total combined charge of +2 to this -2, which equals 0. Here, this is chlorate. Its overall charge is -1. So oxygen, once again, is -2. There's 3 of them, so that's -6. Chlorine, in this instance, must be +5. The +5 and the -6 gives you an overall charge of -1. So let's look at this one. PCl5. Chlorine is the most electronegative element, therefore it's going to get its normal charge of -1. There's 5 of them, that's a total of -5. Okay, therefore phosphorus in this particular situation must be what? +5. Okay, all right. And the reason I bring this up is we've been talking about anhydrides, and I mentioned that a non-metallic oxide plus water produces an acid. And people were saying, well, how do you know it produces HNO3 and not HNO2? Well, I said it's got to keep its oxidation number. So let's look at the oxidation number for nitrogen. Okay, oxygen is -2. There's 5 of them. That's a total of -10 altogether. So nitrogen over here should equal +10. There's 2 of them. Therefore, each one has an oxidation number of +5. Okay, -2, 5 of them, -10 total. This must be +10 total to cancel it out. There's 2 of them, so each one is +5. Over here in nitric acid, oxygen's -2. There's 3 of them. That's a total of -6. Hydrogen's +1. Therefore, nitrogen must be plus 5, so that we have a total charge over here of plus 6 to cancel out the negative 6. If it was HNO2, oxygen's negative 2, there's 2 of them, that's a total of negative 4. Hydrogen's plus 1, that means that nitrogen would have an oxidation number of plus 3, which is not consistent with the plus 5 that we had in N2O5. Here's plus 4, canceling out the negative 4.